1, 0.
Hello and welcome to another episode of Endgame, where everybody talks about a random topic and let's just hope it doesn't get screwed over. Today's hosts are Poklapo, Psych, and a special guest, Joel Moore, who works in geoscientist. And today's topic will be introduced by the hosts. Please enjoy this episode Endgame. Thank you.
Nice. Awesome.
Thank you,
Thanks,
guys.
Gal.
Appreciate it.
Yay. Welcome,
Hi, everyone.
guys.
Thanks for joining us. So even though his name tag says lousy, this is not lousy. Lau is that is his account. Lau is the author of this wonderful world, by the way. But in his headset right now is Joel Moore. And so you are a geoscientist. And how long have you? Tell us a little bit about yourself. How long have you been doing what you do, and what's your background like?
Yeah, so I'm a professor of geosciences at a university in Maryland. I have an undergrad in geology and history, and then got my PhD before I became a professor. And so I've been thinking about climate change since my undergraduate in the late 90s, early 2000s, sort of long-term geological climate change, a timescale of hundreds of millions of years, been thinking about for 10 or 15 years, and I published a little bit of research related to climate change and kind of keep up on the big developments in the field.
Okay, great. What has been your focus for the research that you've done?
My big focus most directly related to climate change was that I measured carbon dioxide concentrations and the carbon isotope ratios in the air in Chicago, Illinois, and looked at how it varied seasonally related to different emissions from natural gas, from cars, and how that varied between winter and summer and that sort of thing.
Okay,
So looking
cool. Great. And so you have you've prepared some like slides and a video for us and stuff. So we'd like to kind of go through that through the material that he's brought for us. And if you have a question about hi Sarah about one of the slides that we have, go ahead and ask real quick. But then we'll save most of the discussion for after the kind of presentation.
Yeah, it'll be about like 15 minutes or so.
Okay, so here's our slideshow.
Nice. And if you just want to move over here, yeah, you can just, nice. There you go.
If you can't see very well, get as close as you can without triggering the stage warning. Okay, so Joel, take it away and let me know when you want to go to the next slide.
Okay, will do. So yeah, I put together some slides. This is going to be pretty short. There's, of course, scads of information on climate change. People have been studying it in part since the 1850s, late 1800s, and lots has been done in the last 40 or 50 years, but just going to give some quick introduction. So one of the big things I want to talk about is that anthropogenic climate change, so human-induced climate change, with most of it being driven by CO2 concentrations from fossil fuel emissions, land use change, cement production, that sort of thing. So over on the right, you can see the CO2 molecule. Something that didn't come across in translation is that lower right picture actually is an animation. So not a big deal, but what you see is when it's animated is when infrared radiation, basically radiation that solar radiation comes in, hits the Earth's surface, and then gets emitted back as infrared radiation. And when it hits CO2, the two oxygen molecules on the end, blue, basically wiggle back and forth. And that wiggling back and forth produces heat, and that's what traps heat in the atmosphere. So CO2 is a greenhouse gas. We've known that since the mid-1800s, and that's a good thing, because if it wasn't in our atmosphere, it would be about the freezing temperature at the Earth's surface all over. So CO2 is a good thing on the whole. What's changing now is that we're emitting a lot of it into the atmosphere. And so quick definition is that when we talk about climate, we're talking about average weather over time periods like 10, 15, 20, 30 years. And so the World Meteorological Organization generally talks about 30 years when they're thinking about weather. And so really nice quote that I found somewhere is climate is what you expect, weather is what you get. So if you think about January anywhere in the northern US, you're going to bet that you want a coat. It could be a chance that you get a 50 or 60 degree day, but it's not super likely. But that would be weather if you got a 60-degree day in Chicago or New York. But on the whole, most of January is going to be pretty cold, and that's sort of more of a climate type thing. So that's it for the first slide, and I think the next thing would be the video, if we could do that.
Video. Okay. All right.
Nice, that's good.
Oh no, come on.
Maybe it'll take longer because we have more people in here.
Maybe. It worked like a second ago. I don't know.
Oh no.
Oh man.
Wow.
It was the coolest video.
Uh-oh. Well,
Was it a button over here that could have led it to work?
I don't think so.
Because that's the only difference, is that I know these buttons were clicked.
Oh crap.
Would it be easier to come back to it?
yay!
Or
Yeah.
It's probably not going to happen,
okay.
unfortunately,
Let
but
Let me try to
That's
open
okay.
up another room, and maybe we just like something got glitched in here, and I can go check real quick if you guys want to continue.
okay.
Yeah, I can kind of
Yeah,
describe
keep
it
going through the
initially.
slides, yeah.
You
Okay,
wanna
cool.
take
Yeah,
over?
sure. Okay. All right. So yeah,
Technical
keep on going,
difficulties.
and then we'll see if the video works in a new room.
And just click it once. There's a slight delay.
Okay,
Okay.
I'll talk about the video real quickly.
Yeah.
So what we can link it in the Endgame channel later, so people can watch it in the future if they want to.
Yes. Nice. Good idea.
So what the video is, and will be if we get to see it, is it's one of my favorite scientific animations, presentations of data. And so what it is CO2 over time. And so we've been measuring CO2 in the atmosphere directly since 1960 or late 1950s. So a guy named Charles Keeling went up on the top of Mauna Loa, the big volcano in Hawaii, and started measuring CO2 concentrations in the atmosphere. And then other people have started measuring it since then, and now we measure it all over the world. And so the animation shows what concentrations look like through time. Short version is they go up. And they vary a little bit by season, but the overall trend is that concentrations go up. And then the video goes back and looks at the ice core data. So we've taken cores from glaciers around the world, in Greenland and in Antarctica and elsewhere, and we can melt those glaciers and measure the concentration of the gases and bubbles in that ice and figure out what the concentration of CO2 was back to about 800,000 years ago now. And so that animation shows what's happening with that. So I think I'll move on to the next slide. Any luck?
Yeah, when I opened up the same exact room, it worked just fine. So I don't know what the
It's probably
know what the
related to the
deal is.
people in here.
Yeah,
Yeah,
I
that's
guess
what I'm
so.
guessing.
I
We
don't know if
posted
it's worth it to
in the
try to move.
Discord. It's okay.
Okay,
I think it's
all
fine.
right.
Yeah.
Yeah, that's fine.
Next.
So I think
Uh,
I can take that again if you want. Oh, next slide.
okay. Yeah, next slide, please.
My precious.
Okay, so CO2 concentrations varied between about 180 and 290 parts per million over the last 800,000 years. So we had glacial periods where there was ice over Moscow and Paris, New York, Chicago. The Antarctic ice sheet and Greenland ice sheets were much bigger, and CO2 concentrations were about 180 parts per million then. In interglacial periods between the glacial ages, like now, concentrations would get up to about 290 parts per million CO2. And then things like methane and other greenhouse gases behave similarly. What's changed in the last 150 years or 250 years since the Industrial Revolution is CO2 concentrations have started going up and up and up. So we passed 400 last year or the year before, and so we're now 30% higher than we were at any point in at least the last 800,000 years. And so what this increasing CO2 means is that temperatures have gotten warmer. So here are some data from the most recent US report on climate that got released late last year. And as if you can see the red up there, red are warmer concentrations, and the average from 1986 to 2016 was a lot warmer than most of the rest of the 20th century. And so you can see some areas of the world, like across Russia, Mongolia, northern China, got really warm, in Brazil and so on. But basically almost everywhere on Earth has gotten warmer in the late 20th century and early 21st century. And you can see the year by year temperatures over in the graph on the left, where you can see compared to the average for the 1900s, particularly in the last 30 years or so, concentrations keep getting warmer.
So for those of you who can't see too closely, this is the year 2000. Back here is the year 1880. So that's has this changed over time?
Yeah, and so the warmest temperature over on the right there is about 2 degrees Fahrenheit, or about 1 degree Celsius, that it's warmed over. I think that's the average for 1960 to 1990. I forget what it is. One of the things that gets a little bit complicated when you're looking at graphs like this is they will often use different baselines to compare them to. So sometimes you'll see 2 degrees Fahrenheit, sometimes you'll see 1.5. It depends what their baseline is. But the 15 hottest years on record have all happened since 1998, and 14 of the 15 hottest years have happened in since 2000. So if there aren't any questions, then I think I'll go on to the next slide, if that's okay. Okay, so this is sort of a still version of what the animation was. So the top you can see CO2, which is a greenhouse gas, and in the middle you can see temperature over time, and in the bottom you can see methane. So over on the left side is 800,000 years ago, and it goes up to the present on the right side. And so you can see across the last 800,000 years, again, concentrations for CO2 were between about 180, 190, and about 300 parts per million. And then you can see over on the far right, they go up to 386. That was a few years ago, and we're up above 400 now. And you can see.
I'm having trouble reading this. So so there's two vertical graphs here.
Yeah. So
okay, this one is CO2.
Yep.
Okay, and then this one is
methane.
Methane.
Yeah, so there are multiple greenhouse gases. CO2 is the highest concentration one, but methane is also a greenhouse gas. So you can see they look pretty similar, not exactly the same, but pretty similar. And
so
then
this just shows that they increase at the same rate over, like, whenever there's an increase in methane, there's usually an increase in CO2 and vice versa.
Exactly. And in the middle is the temperature. And so one of the big things is that these are connected. So you can see shaded in the red across the top of that middle bar are the warmer periods, and the bluer part shaded across the bottom of that middle bar are the colder periods. And so the colder periods are when the ice sheets got big, again, over Paris, London, Chicago, Moscow. And the warmer periods are periods like we're in now between those glacial advances. And then you can kind of see, it's a little hard to see on this graph because they all blur together, but the line on the right goes up.
So obviously every peak has like a trough, whatever, next to it. Like anytime that it's really high, it eventually gets really low. So are we, and I don't know if you get up to this later, but like, are we, like, everyone talks about how we're in this period of warming. Does that mean that we're expecting at some point for, the ecosystem to kind of correct itself and get to some kind of like ice age again that we could trigger or something like that? Or are you just assuming that it's just continuing to get warmer and we're not sure what will happen?
Great question. And so the period that's most similar in the past to the one we're currently in is about midway in the plot, about 400,000 years.
Right here?
Yeah, exactly.
I think. Yeah.
So you can see that's a little bit wider than most of them. So we would expect, if humans weren't emitting CO2 and other greenhouse gases, things would stay warm for probably a couple thousand more years. But what seems likely to happen, best estimates are now that as we keep warming things because of greenhouse gases, we may warm things up enough that we don't go into a glacial period in a few thousand years like we might have without any sort of human interference or anthropogenic interference.
Okay.
And what do the glacial periods, I don't know, like what do they do? What happens during this phase to the Earth?
So ice sheets spread out all over the place. So the Antarctic ice sheet, there are two big ice sheets in Antarctica, those get bigger. There was a couple of ice sheets on North America. One came out from about the area of the Hudson Bay. It spread down to New York. So Long Island Sound is basically where the southern end of it was in the eastern U.S. The southern end went down into Ohio, into Nebraska, and places like that in the Midwestern U.S. And so you get in New York and Chicago, you had something like a mile thick of ice from these huge ice sheets. So it's sort of like you pour pancake batter on a flat surface and it spreads out. That's what happens with the ice. So you keep getting snow, it builds up, it doesn't melt during the summer, and so it builds up into big piles of ice and then it spreads out.
If you like walked up, I'm having a hard time imagining this. If you walk up to this, do you see like a wall of ice like on the landscape?
You do to some extent. It gets thinner. It's not a mile thick right at the edge. That's more, back from the edge. But if you look at pictures of Antarctica, you see these big walls of ice at the edges of Antarctica. So Antarctica at its thickest point is 2 miles thick. So at the edge of Antarctica, it's not 2 miles thick. It's probably a few hundred feet thick. But in the middle of Antarctica, these ice sheets are, 2 miles thick.
Okay.
Other things that happen is the temperature is cooler by about 5 degrees Celsius or about 10 degrees Fahrenheit globally. Sea level is about 400 feet lower than it is today because so much water has been locked up in these glaciers that the entire ocean level drops 400 feet. So things like the Chesapeake Bay were completely dry 20,000 years ago during the last glacial maximum period. And so things like, Pennsylvania, places like that would have been tundra. They would have looked like northern Canada looks like now during that trough, exactly where you're pointing at.
Is that
there.
right there? Okay.
Yep.
Cool.
So great questions.
Okay.
So if there are no further questions, let's go on to the next one. Okay, so as we emit CO2, one of the things that happens is not all of it goes into the atmosphere. So when you drive your car, when an electrical plant burns coal or burns natural gas, CO2 goes into the atmosphere, and about 50% of it stays up in the atmosphere. About 25% of it gets incorporated into vegetation and into soil carbon, and about 25% of it gets dissolved into the ocean, sort of like CO2 in soda, right? You open a soda and you hear that CO2 coming out. So CO2 is being dissolved into the ocean all the time. One of the problems with climate change is as things get warmer, basically most of the way the Earth responds will make things even warmer. So for example, warm water holds less gas than cold water, right? You probably all know this. If you've opened a warm soda versus a cold soda, warm soda, right, you get a big burst of gas versus if it's been in the fridge for a while, you just get a little as it comes out. And so that same sort of thing happens in the ocean. So as the Earth gets warmer and warmer, the amount of CO2 that's going to dissolve in the ocean will be less and less with time. And one of the big things that I didn't fully internalize until a couple of years ago is most of the heat that's being trapped by CO2 and these other greenhouse gases is going into the ocean. So about 93% of it's going into the ocean. So that 2 degrees Fahrenheit of warming we've seen in the last few years in the atmosphere is only 2% of the total heat that's getting trapped by CO2. And so as you warm the ocean, you get more evaporation, you get more precipitation. And so there are lots of effects of climate change, which is why I call it climate change rather than just global warming, that more water in the atmosphere means you're going to get more precipitation in a lot of places and lots of different effects like that that might not be immediately obvious.
I mean, I've
Yeah.
like noticed, I mean, and I don't know, because I think one issue here and why it gets like political a lot is that our individual, the idea of sampling, so like our individual experience is this tiny sliver, a tiny sample of like the weather and everything like that. And it's not necessarily representative of the climate. But given that, like I've been driving in the Tennessee area and stuff like that recently, and the torrential downpours that I've experienced, like extended torrential downpours where I can't even see more than two cars in front of me on the highway. I've never experienced anything like that before, and now it's all of a sudden it seems a lot more regular. Like that happens a lot more often, and I don't know if it's because of this or if it's just by chance. But I mean, I think it's because of this. I mean, it seems like more precipitation. So I'm curious what your thoughts are on those kinds of observations.
Yeah, you're exactly right. So a warmer atmosphere can hold more water, and then when it falls out, you get more rain. And so statistically, when you look at the northeastern U.S., I think down into Tennessee, there's been about a 60 or 70% increase in really heavy rain over the last 25 or 30 years. So definitely, it's not just Tennessee; it's all over the northeastern and mid-Atlantic U.S. And so that's definitely in the statistics for the precipitation for what people are seeing. But yeah, you're absolutely right about one of the things that can be tricky is your personal experience, what you see when you step out your front door versus what's happening globally. So maybe some of you experienced the polar vortex a few winters ago in the eastern US where it was rather cold for a month, several weeks. And so there was a senator who took a snowball onto the Senate floor and said, it's snowing in February or March. It doesn't usually do this. Therefore, climate change isn't happening. But when you looked globally, when you looked at, say, Siberia was as much warmer as the eastern U.S. was colder than normal. And so you really have to look at the whole globe and at the whole statistical picture.
How many people out here, thumbs up if you're outside of the United States? I'm curious what our proportion of people outside the U.S. is. I see some people I know are outside the U.S., but
okay,
I'm curious.
Slipper's outside. Yuval was here for a bit, but I think he had to go.
And Rubik, I know, is outside the U.S. Okay. Zani Whoop is outside the U.S. Cool. So yeah, we have I guess a few people outside the U.S. as well.
Okay.
Yeah. Is this from YouTube?
No, but Dr. Blair's right here.
Oh, Dr. Blair. Oh, behind you. Cool.
Dr. Blair was saying, so since he's saying that with the warming that we might be able to avoid this ice age, does that mean global warming is a good thing, potentially compared to the negative connotation it typically gets? I mean, recycling is a good thing and potentially horrible effects, but if preventing an ice age is a cause of, let's say, global warming, then wouldn't we avoid all the deaths and extinctions that would go with it?
Good question. So I think I would say short version is no. So the warming we're going to see is going to happen in the next few decades to 100 years, whereas the ice age is, a few thousand years out. And one of the big things with climate change, anthropogenic climate change, is the rate at which things are happening. So the warming is happening much, much faster than anything we see in the geological record. And so the organisms we rely on, wheat, corn, and then domesticated animals, those are all adapted to a relatively stable temperature. So Earth temperatures have been pretty stable on the whole over the last 11,000 years since humans have been doing agriculture and domesticating animals. And what we're looking at in the next 50 to 100 years is taking us outside the range, well outside the range of where the temperatures under which those species of wheat, corn, etc., were developed.
The other thing I kind of want to note is that the current state of the environment as it currently is, before it's even getting any worse than this, we are experiencing a mass extinction in organisms across the planet. It's happening really, really quickly and at a rate that's been unprecedented for millions and millions of years. So extinctions and everything are happening at a rate far swifter than I think anybody considers acceptable. I studied biology, and that was talked about quite a bit and still continues to be that still continues to be the case. I don't think it's let up any since
Right.
I was doing
Yeah,
that.
and there are different reasons that, even for selfish human reasons, we might want to preserve some of those species because they might have chemicals that might be useful for preventing cancer or curing cancer or that sort of thing.
Yeah, all
and then
sorts of
there's, of course,
reasons.
the intrinsic value of those too. Any other
Okay.
questions?
And I want to get. Oh. Yeah.
I mean, I said that. Okay. So,
What did you say?
I
Your
have two
mic's pretty
questions.
low. Okay.
Yeah, I know. I can fix that real quick, but first thing I want to get out is, number one, since I've known that, because this was taught in my chemistry class, and we're obviously studying that the more CO2 is in the atmosphere, the more acidic the ocean gets, because the ocean takes quite a lot of CO2 out of the atmosphere, or get the heat trapped. So, basically, so based on your evidence, it's suggesting that we are experiencing rapid acidification in the ocean, which could lead to even more of an extinction event, like Popo's saying, right?
Absolutely. And so we're already seeing the effects of some of that acidification of the ocean. So in the northwestern U.S., in Washington State and Oregon, acidic waters that have come in from the broader ocean are affecting oyster hatcheries and other things where there are economic impacts and industrial impacts of the ocean acidification. But yeah, we're definitely seeing big impacts, and the oceans and fisheries are among the most heavily hit and where a lot of the extinctions are happening. And then when you throw acidification on top of that, that will, like you said, make things even worse.
Yeah, I do live in Oregon, so that's something we're definitely watching out for as far as environment goes. And number two is that you're also describing how when the water is more warmer, it doesn't hold as much gas as if it was cold water. So this is also, I heard scientists explain, as the reason why hurricanes are becoming more frequent and a lot more stronger.
Yeah, and that's an area that's we know less than other areas, but yeah, that there are a lot of people who think that, yeah, warmer ocean basically provides more energy and more fuel for hurricanes to be even more powerful. Whether that's happened yet or not, it's unclear, but yeah, that's definitely a very real possibility.
Yeah, they said Hurricane Sandy, which was a perfect example of that scenario, where it's gone a lot stronger than it would have been.
Yeah, and that's another thing with hurricanes like Hurricane Sandy is you have sea level rise that's happening because of warming. So water expands as it gets warmer, and then the ice sheets are melting to some degree as well. And so a storm like Hurricane Sandy, you have the winds and the low pressure system, and then when you have sea level rising as well, then that brings even more water into developed areas like New York. And so it's a combination of a couple of the factors that are increased due to climate change.
Yeah, I have some doom questions for you, like about our future and stuff, but I'm waiting. I feel like I want to wait until
we're all gonna die.
I'm a big like collapse person, so yeah. But yeah, let's get through the slideshow first, and then
next slide.
Okay. Yes, please. Okay, so here are some temperature projections. These are from a few years ago, but on the whole, the model projections have stayed pretty consistent. There's a really good video that I can pass along the link to that shows model predictions starting back in the late 80s up until present, and they've been pretty consistent with what we've observed. And so in the top left, you see projected warming from 2011 to 2030. Top right is 2046 to 2065. So this is sort of business as usual scenario where we don't do anything to reduce the amount of CO2 and fossil fuels we're emitting. And then on the bottom left, you see the end of the century. And so what you see is that things get warmer over the course of the century. You see that land warms up more than the ocean. That's important because that's where we live, right? So in the bottom left scenario, that's a scenario in which temperature goes up by 3 degrees Celsius or about 6 degrees Fahrenheit over the next 80 years or so. But on land, it warms up even more than that. North America, you're looking at 3.5 to 4.5 or 7 to 9 degrees Fahrenheit warming on average. And then there are lots of impacts of that. Things like pest insects that would normally be frozen out by cold temperatures survive through the winter, and then they can eat trees and cause deforestation that affects water supply in the Rockies. We're already seeing this now. And so there are lots of effects of that we're already seeing currently. And one of the key things, one of the sort of doomsday and scary scenarios is you see the purple up at the top in the bottom left picture. So that's, 6.5, 7.5 degrees Celsius, or about, 12 to 15 degrees Fahrenheit. And that's happening across the northern part of the northern hemisphere. And most of that is currently permafrost. So it's permanently frozen. And what's locked up in that permafrost is lots and lots of carbon. And so as we start to thaw that permafrost, there's potentially a bunch of carbon that could come out into the atmosphere. Yeah, and methane, a lot of it is sort of reduced like swamps, right? And so those tend to release methane, which is an even stronger greenhouse gas than CO2. So yeah, exactly.
So do these models account for that release?
No, they don't. And that's one of the...
Okay.
No, it's one of the things that people are working on building into models, but that's one of the areas we don't know much about. And people are certainly measuring methane emissions across Siberia and northern Canada, Alaska. But that's one of the areas that, yeah, a lot of the unknowns where we kind of have some idea this might happen, but we don't know what temperature, like does it all come out at once in a big poof, or does it slowly come out over time? Those make a big difference in terms of what temperatures and life on Earth looks like. But that's a known unknown. There might be the unknown unknowns where things we know don't even know we don't know. So. Okay. So if there aren't any questions on this, then we'll maybe go on to the next slide. Okay, so as I said, more than just temperature. So climate change. So we already talked about this a little bit. As the atmosphere gets warmer, as the ocean gets warmer, there's more water in the atmosphere, and it falls out of the atmosphere more quickly. And so the top plot shows precipitation intensity. So the blue and purple shows more intense precipitation, heavier rainstorms like you talked about in Tennessee. And so you can see in many of the wet areas of the world, northern North America, Europe, the rainforests in South America and Africa, those get more intense rain. The areas that are already dry, like the Sahara Desert, like the southwestern US, those get even drier. And then most of the world has more dry days. And so you see on the bottom graph, most of the world is yellow, red, and pink. So that means there are more days that are dry, that don't have precipitation. So if any of you garden or grow things outside, you know what plants like are steady precipitation, right? Low rates of rain so it can infiltrate into the soil rather than running off. And so what temperature or what precipitation looks like going forward is you get more rain, more flooding, and then you have more dry days in between because of the warmer atmosphere. Basically like a bigger sponge, a sponge that can hold more, but when you squeeze the sponge, much more comes out. So if there aren't any questions on this.
I just have a quick add-on to that, just to iterate your point. So where I live...
we can't hear you very
breaking
well.
up.
You're... Oh.
Yep.
Oh, there he goes. Oh, bummer.
All right, we can just continue
well, we'll get him when he comes
we'll go back. Yeah.
Okay. Should I move on? Next one?
Yeah, please. That'd be great. And I think this is the last slide or second to last slide. And so one of the things I already mentioned that as you get warmer ocean water, it expands and you get higher sea levels. Sorry, 1 second. That would be great, actually. I've got a water bottle on the floor. So I'm going to take a quick pause for a drink of water. That's okay.
It's nice that you have a personal assistant.
Yeah, isn't it?
I can hear him in the background.
Yeah. Hello.
Cool. I'm good.
And now a word from our sponsor. Have you heard about the show called Endgame? It's a wonderful new show that is on VR Chat where we talk about the end of the world. Oh, don't forget about its various technologies as well, such as the host's very favorite one, teledictonics, because we haven't talked about that for such a long time.
Not yet. I know.
Oh, you're right. It's been a
Teledictonics
while.
coming soon.
Anyway, join us on the Endgame show at 10 p.m. Eastern every Wednesday. Back to you.
Thank you.
Nice, thanks. So this is from the latest U.S. government national climate assessment that came out late last year. And you can see that there's projected sea level rise across most of the lower 48 states of 3 to 5 or 6 feet, with a lot in Texas and southeastern U.S. and a lot along the eastern U.S. And so 3 to 6 feet may not seem like a lot unless you live near the coast and you have some sense for what that means. But to put that in real terms, what we're looking at in the eastern U.S. is floods that used to happen along the shoreline due to high tides, due to storms, that used to happen every 5 years. For the next 20 years or so, those are going to start happening 5 times a year rather than every 5 years. And they're already seeing a lot of this in Florida and elsewhere where you have sunny day, but you get these high tides that come in and you get flooding even on a sunny day, not in a storm, not when they would have expected it even 5 or 10 years ago. And so projected sea level rise is a problem because something like a quarter of all humans live within, few tens of miles of the coasts all around the world. So if there aren't any questions, I think that's it for this slide. And I think this might be the last slide.
Yeah, looks like it might be.
Okay. So I have a couple questions because I've always been wondering about like the future. Like, are we, one is when it's going to be like unanimously accepted almost that whole, wow, the weather is changing. Like, this past year has seemed pretty crazy weather-wise with the polar vortex and things like that happening. It's like, once we have that 5 times in a row, is it just going to start to become apparent? And then what is the best way to actually prepare strategically? For example, it doesn't seem like it makes much sense to buy real estate. A lot of us, a lot of VR chat people are younger, something like that. So it seems like it doesn't make as much sense to buy real estate necessarily, or like if you're planning on living somewhere for 30 years, in a place that's going to be negatively affected by sea level rise and stuff like that.
Yeah,
so
and I
what are
think
your thoughts on that?
That's an area where things are definitely in flux. They're definitely developing. There was a good New York Times story a few weeks ago or a few months ago about there are some companies, tech companies, that are trying to fill the gap between these sort of 20, 30, 40-year projections on like the scale of the East Coast to sort of smaller scale and more detailed time scenarios. So a real estate developer in Charleston, South Carolina is thinking about redoing some old warehouses along the wharves, and they're trying to decide in 20 years will these be underwater or not. And that sort of detailed thing isn't in these sorts of studies, and so they're trying. Some tech companies are trying to step in, build off the scientific research that's out there, and come up with these more detailed scenarios. But yeah, and that's something I think more shareholders are starting to think about. Certainly, some activists, sort of pensions and groups are trying to think about are bigger companies that are publicly held thinking about the possible ramifications of climate change in the next 10, 20 years. I think that's something that's pretty important to be thinking about.
Interesting. Okay. And Freeman, are you in line to ask a question when you come up?
I mean, it's not like really a question. It's just from the UK perspective, a lot of the big weather events such as El Nino, which we don't really get much information about how it's changing, etc. So it will be great if you can just explain to me how is that affected by climate change.
And maybe explain what El Nino is too as well.
Yeah, hopefully you've all seen, or you should look up the Chris Farley Saturday Night Live episode or skit about El Nino. It's pretty funny. From back in the late 90s, which was I think the biggest or second biggest El Nino on record. That was the first time that at least the American public started to think about El Nino because it was on Saturday Night Live. So if you think about the Earth as a sphere, right? And it's easy for those of us in the mid-latitudes to forget that most of the area of the Earth is near the equator, between the Tropic of Capricorn and Cancer. And so evaporation of the ocean, warming of the ocean there, like you have in El Nino events, can affect the weather globally. And so what El Nino is it's when the tropical Pacific Ocean warms up by more than half a degree over a couple-month period. And so I think it's looking like we're maybe potentially heading into an El Nino cycle in the next 6 months. There was a pretty strong one in 2015, 2016. There was a really strong one back in 1998. And then La Nina is when the temperature cools by more than half a degree Celsius below normal. And so you have things like heavy rains in Australia when you get El Nino events. Is that right? Yeah, heavy rains there. Or sorry, droughts in Australia. You get heavy rains potentially in Peru. It changes fishing. So fishing off of Peru and Argentina, which is one of the biggest fisheries in the world, gets a lot worse during El Nino events because the fish like cold water. The cold water comes up from deeper in the ocean and has lots of nutrients in it. And during El Nino, that cold water stops coming up as temperatures warm, and so it affects fisheries. But the way it would affect you in the UK and affects us in the US is it affects moisture coming out of the ocean, going up into the atmosphere, and our precipitation systems, our temperatures to some degree can be affected all around the world due to El Nino events. How that's going to change due to climate change, that's an area that's definitely still on the forefront of people trying to figure out what might happen. That's definitely something we don't know a ton about at this point.
Thank you very much.
I have a question.
So we'll get to sleep.
Like one of the most distressing things that happened recently, I think in well, there's a lot of things, but like in regard to this, is that like the what is it called, the government institution to study the environment is no longer like allowed to use the term climate change, and they're not allowed to put that stuff on their website anymore. And I find like the politicization of environmental study to be really interesting, because it seems to me that like the Earth is like, it belongs to all of us, and it's like it's our entire environment, and if it goes south, like we go south, like we're all so dependent on it. It seems natural to me that studying it would be a common effort, like something that we would all participate in. And so like the fact that it's become a political issue, and like if you believe in climate change, then you're a liberal, and if you don't believe in climate change, then you're a conservative. Like that seems to me really backward. And I'm curious about what your thoughts are about either why that's happening, or do you see that in the scientific community at all, or like what is your like how much have you encountered this aspect of it in your work and in your studies and in the academic environment?
So I personally haven't encountered it as much because I'm in a university and in a state, Maryland, that's a little more liberal. But yeah, and I definitely have colleagues who work for government science agencies who have and are encountering that sort of thing. It's definitely been politicized more so than it used to be. I mean, when John McCain was running for president back in 2008, he had a climate change plank in the party platform that they were going to do something about it. So things have actually kind of gone backwards on that front in the last 10 years or so. This is not science. This is a little more politics. But essentially at this point, there's only one major party globally in the developed world that doesn't see the scientific evidence for climate change. And that's the Republican Party in the U.S.
Yeah, I feel like a lot of that is also the influence of money in politics and lobbying and, big corporations, oil and things like that, saying, trying to delay the inevitable, which is, regulation and shifting to newer, cleaner energies. It's just not in their monetary interests. So therefore,
I mean, like money in politics directly affects like policy, but what we're seeing is like sociological, like it's in people's heads differently than that. Like people lobby about I don't know, like huge corporate mergers and intellectual property law, but like like people's opinions about the environment can get so like they're so personal. I don't know.
Right.
It's not really it's not yeah, I know that your specialty is science and not socioeconomics, but like it seems puzzling to me that it's happening at all in the way, you know, that the conversation is happening in the way that it is.
I agree. So two things I'd like to say. One is there's this really great book, Merchants of Doubt by Naomi Oreskes, and I'm blanking on the other author. Came out a couple of years ago, and so they looked at some of the institutions and money behind some of the more scientific parts of people fighting climate change. So Fred Singer, who's at Cato Institute, and other people. And if you look at the sort of money and groups who tend to be against climate change in the U.S., they're often the same groups who were against sort of working on CFCs and ozone. They were some of the same groups that were fighting tobacco causing cancer. And there's sort of this thread that it stretches back decades now of the same groups, funding sources, and often even the same individuals who are sort of pushing that line. So that's one point. And then the second point is, unfortunately, this sort of overlaps with the sort of increased partisanship in U.S. society. And so people become sort of entrenched with, you know, I think the same thing as my party. I'm a Republican or I'm a Democrat. So I think these set of things, and climate change has been wrapped into these set of things. And again, more so now than it was even 10 or 15 years ago, where it was much wider spread. And it's sort of become party orthodoxy. And there's Bob Inglis was a congressional representative from South Carolina, who Republican representative, who became convinced by the evidence for climate change, and he ended up getting primaried out by a more conservative person. So there are a lot of incentives to, even if you're a Republican who is convinced by the evidence, not to be particularly vocal about it, because you might, someone might basically come after you for that.
That's so unfortunate, because it shouldn't, like, there's nothing inherently political about this topic. Like, it's not naturally geared towards one civic arrangement or another. It's just the state of the world. Although that first point you made was interesting. Like, the same people have been kind of pushing in the same direction for so many years. Like, maybe they've obviously like got the tools to sway public opinion and probably capitalize on that partisanship.
Yeah, I think that's right. Yeah, and I think, with environmentalism and partisanship, again, it didn't used to be that way. Some of the founders, Earth Day, were Republicans. The EPA, Environmental Protection Agency, was started under a lot of the U.S. environmental regulation was started under the Nixon administration, a Republican president. And so, again, it definitely wasn't that way for a long time, but has become more partisan over time.
Okay, Slick Rick?
Yeah, thank you. I guess my question, since this is Endgame, so if you talk about like the future of climate change, you're talking timelines like 50 to 100 years, whereas we're approaching a technological singularity, which people say might happen within 20 years. So I guess I'm just wondering if we really need to worry about climate change so much, because, in the future, before we reach the really critical parts, we'll have the ability potentially to fix all of these problems that we're causing right now.
Well, what kind of, so the technological singularity is, it's like a threshold that we're, that we might cross, if we get to it, right, where we can't predict what will happen with technology. I don't know that it's a sure thing that, like, every problem is going to be able to be solved at that point. We just don't know what's on the other side. But that is an interesting question, though. Like, are there technologies being developed that you've seen that contribute to, like, that could help this? Like, I've heard of those towers in China that like will like absorb carbon from the atmosphere. I've heard of like biotechnology that is being used in like wetlands and stuff. Like, are there any like promising technologies you've seen that could help us with this issue?
So there Yeah, there are a wide range of those. Some are sort of adaptation, building your infrastructure and other things to be more adapted for, say, heavy precipitation. So one of my favorite stories from a few years ago was Chicago has started putting lighter colored pavement in its alleyways and parking lanes because that reflects more sunlight rather than having it absorb and warm things up. And it's making more of it pervious, so it has holes in it, so that more of that precipitation can infiltrate and then maybe water some of the roadside plants rather than running off and causing flooding in streams. And so there's some pretty simple, well-established technology that if we start building it in, it's a little more expensive and requires a little bit more creative thinking, but we could just start adapting to things. And then, yeah, there is technology potentially to pull CO2 in, and they're actually doing an experiment in Iceland, which has a type of rock, basalt, black rock like in Hawaii as well, that can basically suck up a lot of CO2. It's a pretty slow process, but if you inject it deep into the earth, you might trap it long enough that that process can happen. And so there are definitely a lot of these sorts of technologies that are in their very initial stages. The question is, can we make them widespread? Can we make them ubiquitous? But just in terms of alternative energies, both solar and wind are much cheaper than they were, even 10 years ago. So they're cheaper than nuclear energy. They're basically competitive on price with coal energy now. But then you have political factors weighing in on that, where basically coal isn't all that economically viable anymore, but then you have parts of American society that then want to subsidize it to keep it up and going, even though coal is one of the worst offenders in terms of CO2 and greenhouse gases, plus pollution that we breathe. Sorry.
Well, I think it's interesting because what Slick is talking about too is like, what about the other advancements in tech? I mean, at least this is what I got from your question too, is like other advancements in technology that are going to change the whole way we're living in our society before we get to the consequences of climate change, like the extreme consequences, and even 50 years from now. What about 20 or 30 years from now, for example, and this comes back to coal, when automation has replaced a lot of jobs. So like once we accept, like if automation replaces a lot of jobs, and then the whole coal argument of like we need people to have jobs for coal, we're going to have circumvented that, or we're going to have overcome at least the argument that we need to do something to create jobs like that, because fast food and all these other places are, automation might kind of threaten those industries. So it's like maybe those kinds of changes will have unintended effects on the kind of environment.
We're already there in terms of coal. I mean, there are fewer people working on coal now than there are working on solar. The solar industry is bigger than the number of people working on coal. And so because of automation and other things. So, but individuals who lose their jobs understandably aren't happy about that. And so then you have this sort of economic struggle on that. Back to the singularity, and one of the key things is, sort of globally under the UN and basically most of the nations of the world decided 15 or 20 years ago that getting above 2 degrees Celsius above sort of background temperatures constituted dangerous anthropogenic interference. And so basically we have to start taking steps in the next 5 to 10 to 15 years to not cross that threshold. And so there certainly will be technologies coming in the future.
I've heard that it's like way too late for that, and we should have started taking those steps like 30 years ago. Is that like, which one was kind of the more accepted like understanding?
I think that's maybe slightly on the grimmer end, but there certainly is some evidence for that. It depends on sort of what your threshold is. I mean, there's some evidence, certainly not locked down yet, but there's some evidence that we've lost the Greenland ice sheet. It's going to melt. And then the question is, does it take 500 years to melt, or does it take 150 years to melt? Because that has really big implications for how quickly sea level rises.
Rick, sorry, I was curious about whether you had a like, what do you envision happening that might negate all this? Like, what form of transformation could we undergo that would make this kind of not a threat anymore?
Like we could have genetically modified livestock and crops so that they can survive warmer temperatures. We could have strong AI that teaches solutions that we can't think of on our own.
Oh, I like that one.
And then
Would be
if we
nice.
have like a post-scarcity world, hundreds of millions of people that are living along the coast, they'll be able to move somewhere where they're not flooded.
Okay, yeah, you bring up some good points. Thanks.
I like that. Okay.
Okay,
yeah.
How bad is my microphone?
It's okay.
Okay, so I've got two questions. If that's it, that's fine. I can come back.
Yeah, sure.
First question was, how far are we to a point where we do more good than bad?
What do you mean by good?
Well, you said there's more people working on solar than coal, but I'm pretty sure that coal does more bad than solar does good. So how far are we to have more people and more effects on good rather than right now more
like a net positive on the environment?
Yeah.
That's a great question that I'm not sure how to answer. I think we're sort of going in the right direction, and it's sort of getting together social and economic forces to help maybe speed that up even more. But I think in a lot of ways we're heading in the right direction. I think that's important to remember. And so a couple of things that I talk about in class, because this is kind of a depressing topic in a lot of ways, is I've started beginning this lecture by saying, children living in poverty have dropped by 50 or 60% in the last 20 years globally, and many fewer people starve to death than did 20 or 30 years ago. So humanity has come a long ways in the last 20 or 30 years, even in the midst of the warming we've seen. And so there's lots of really great things happening in the world. They're certainly not guaranteed to keep happening, though, and so that's what hopefully we need to think about and discuss, so we can come up with ways to keep things going in the right direction rather than starting to go in the wrong direction. So I'm not sure if that exactly answers your question.
No, I guess it is difficult for you to answer, but no, I understand. It's going to take time. We might see a point where, you have the data, so at some point you might be able to see, okay, we've reached a point where it's not going as fast as we expected. So maybe we'll see at some point. My second question was, because you talked about people coming out of poverty, do we expect at some point when third nations actually do reach a point where they are in need of technology, food, and all the other things that we have, could all the do we are trying to make be negated by the fact that all these people will have to reach a level of living, a standard of living that will basically requires even more than, and we won't be able to provide as much?
Yeah, I think, and that's definitely sort of beyond the scientific, but that's a good question. I think one of the sort of hopeful sides from that is hopefully they sort of leapfrog us. So in Africa and parts of Southeast Asia, much of the developing world, they never got landlines like we had in the US and UK and other parts of the developed world. They went straight from no phones to cell phones, right? And so hopefully moving forward, some of those same sorts of things happen. So rather than having really big power plants, we have more of a distributed grid sort of system where people have little solar and they have batteries, or they have ways to pump water up during the night that then runs down during the day and generates electricity. And so having a more distributed system that's also greener and less carbon intensive could be a way that we move towards people's standard of living continuing to increase, and the nations that aren't as developed at this point, while still letting them come up to a similar sort of standard of living that we have. If everyone lived like, particularly Americans or Canadians, and to a lesser extent Europeans, basically Earth probably can't sustain that sort of level of intensity of water usage, carbon usage for very long. But hopefully, again, they skip some of the steps that we're currently in.
Yeah, like as greener technologies develop and become cheaper, like if we had the infrastructure to support and the infrastructure and the focus to support solar and the way we have to support coal and oil, then like it would be super duper easy and cheap to get solar power in wherever, you know, because you could just you'd have all the resources available to just set it up.
Right. Yeah, definitely.
Okay.
More question. If at some point the data were to show that it is too late or that we wouldn't be able to, I don't know, undo what we've done, would it be your scientific duty to let the people know, or would you keep that information and try to push as much as you can to try and maybe revert what the data show? Or at some point is there a way when you can say, okay, now it's too late, we fucked up, it's the end?
Right. That's a good question. I think, to use your language, we can fuck it up more or fuck it up less, right? And so if we don't do anything, then we just sort of skyrocket, right? So I think, some people have been talking about climate change for 30 plus years now, and some people think we've already crossed certain thresholds that it's too late to get back behind. But yeah, I think the scientific community is relatively open. We like to argue. We like to hash things out. We're generally not trying to hide things. Sometimes it can be hard to get it out to the general public, depending on who's paying attention. But scientists don't tend to be particularly quiet or secretive, in my experience. So I would say if people who are working on some of the modeling and some of the measurements of temperatures now start figuring some of that stuff out, people will hear about it before too long, at least if they know where to look.
Cool. Thank you.
Yeah,
Thank you.
All right, last two questions, because I know we're hitting an hour here. So, Bill?
Is my mic working?
Yep.
Yeah.
Okay, suppose we put a gigantic orbital mirror in space that reflects off infrared frequencies. How would that help, if any?
Sorry, can you say that again? You talked about a mirror in space that will reflect infrared frequencies?
Yeah.
I'm not quite sure what.
I think the concept is, what if we were able to reflect some of the heat that we're getting from the sun away from us, instead of letting it hit our atmosphere and warm us up naturally by that cause, I think is what they're going for.
Artificial ozone?
So I think that's one of those things that it starts to get pretty complicated pretty quickly, because if you stop solar radiation from coming in, then plants can't grow as well, and you might change where water evaporates, so you might change what places are getting rain and what places aren't. And so, because if you block it out, you block out visible light. That's what's coming in from the sun, UV and visible light. It's not until it hits the Earth's surface and then gets re-emitted that it's infrared radiation. And so if you block out visible light, then we see less, plants get less of the energy they need for photosynthesis, and so that potentially becomes problematic. Sort of maybe an easier way to do that than a mirror in space is you put sulfur into the stratosphere. And so that's what happens when a volcano erupts. So Mount Pinatubo was the last big eruption back in 1991, and that cooled the entire Earth by, I think, 1 degree Celsius for about a year. And so that is one of the geoengineering solutions that some people have proposed, is you put lots of sulfur into the stratosphere. It basically does exactly what you said. It sort of blocks some of the solar radiation, but what if you're the US doing it or you're China doing it, and affects the precipitation of countries nearby, affects how the crops grow.
To agree on that. That doesn't sound very likely.
Yeah, and so that's one of the things that we know it would work in some ways, but we don't have much of an idea of what. Exactly right. Yeah. Exactly right.
Yeah, we don't have a laboratory to test this on. Bummer.
And we have computer models, which in some ways are something of a laboratory, but they're not reality. They're getting better at describing reality, but they're still a long way from it. And so what if we're missing? Yeah, exactly. What if we're missing some important thing that gets tweaked by this sort of blocking of light? Yeah.
Interesting question.
Yeah, thanks for your
definitely.
question, Tim.
Yeah. Okay, last
Gal.
question, Gal.
All right. Take 2 on this, since I disconnected while I was saying this.
Welcome back.
Welcome back, thank you. So, what you were saying earlier about how as we're getting warmer, some areas are going to get drier and some may get a little more wetter, and it's not going to be in short spouts, it's going to be in one big spout, obviously. So, my examples where I live in Oregon, we have 300 days of sun, which is called the high altitude desert. It's not exactly sandy desert, but you get the point, it's dry. And so, last winter, or no, 2 winters ago, we had, normally when we get snow or a snowstorm, it's not that bad. We have a little more plantations, but it's fine. But 2 winters ago, we had so many snowstorms that affected the school system itself. It actually collapsed a school gym an hour before children were going to go. But the most important effect that it had was that it had a lot of plants, a lot of sheepgrass, whatever, a lot of plants that tend to grow with a lot of water into the forest. And so when that dried out, basically it caused a huge wildfire crisis in our state, which
it's been happening
to the point that there was so much smoke that you literally everywhere you go there was smoke in the air. You could literally see it. It started causing a fog effect as well. So that caused a lot of conversation within our government, like, how to prevent this? We need more money to fight fires. So that's kind of the thing you're telling us, that we get more precipitation, whether it's in rain or snow, and that's going to have a lot of compound effects on the environment, like what I was explaining.
Yeah, similar
absolutely.
things happened in California as well, and multiple places as well, like fire. You know, I don't think about fire as a consequence of, like, the ocean's getting warmer, but you know, it's all connected.
Yeah, absolutely. Yeah, and so that might have been an El Nino event. I'm forgetting the exact timing, but that might have contributed to that as well. But yeah, you're absolutely right. It seems counterintuitive that wet equals fire, but it can 3 or 4 or 5 months later. Yeah, and there are all sorts of, it, like you said, it's all connected. So you start pulling the string somewhere, and it all ends up being tangled up and connected, and which is part of why, in my view, I think we the sooner we do something, start making some progress, the better.
Cool.
Thank you, guys.
All right.
Yeah, thanks. Well,
Thanks.
Thanks everyone for your questions, and thanks for coming on the show.
Yeah, thank you, Joel. This is great.
This is really interesting. Yeah, and so I guess we can take a picture. Any last thoughts, you guys, before we close out?
Man, I hope we make it and don't kill more organisms than we have to.
Yeah, I think a lot of humans are going to die in the next 50 years, and especially in third world countries. But you know,
thanks a lot.
I hope I'm wrong.
Nice place to end the episode.
Yeah. Sorry.
Yeah.
I mean, this is about climate change.
I do have one.
Let's go with the technology. Hopefully the technology, but we gotta
the technology is great.
spend the money to research the technology too.
I do have a
We're
one
gonna go
final
turn off
thought,
the
just a quick
stage.
one.
Okay.
Okay.
So, I think
I'll
a
turn
really
off
good
the
question
stage,
to
maybe.
ask ourselves is, if we're not able, the question is, it's not how we get there, but how do we limit the damage if we're not going to make it too late? Because we should all say there's a certain cutoff point until we are too late to cross the 2 Celsius standpoint. So we have to prevent so if we can't stop that from happening, then I think it's all a matter of how do we limit the damage that it's going to cause rather than trying to prevent it.
Harm reduction.
Yeah, like once we have the information, what's the right thing to do? What's the right way to proceed, and how can we, take care of the place that we're responsible for?
I mean, the sad thing is, even if you do have the information, half the time, every government wants to, make their country, develop better, and usually that means, well, at the expense of, the climate.
Others.
Sure.
Yeah.
So, like,
So
Values have, values like that are a part of it and everything.
Quick positive note to end things, if I may.
Okay.
Yes.
So
no, you're not allowed to have any. No, kidding.
So CFCs, right, which ozone hole and everything. So CFCs are a greenhouse gas, a really strong greenhouse gas. And so by eliminating and reducing CFCs, we've actually, temperature hasn't gone up as fast as they expected back in the 80s. It's been, I think 0.2 of a degree Celsius cooler than expected because we stopped producing so many CFCs. So we have cases in which we have been successful in reducing harmful gases, and it's making a difference. So we are making progress.
Oh, good.
Yay!
That is good news.
I like that.
All right.
All right, the
Great,
stage is
thank you.
off. So
All
if you guys
right, come
want to
on
come
up,
up and take a
everybody.
picture, we just take a picture as well. Let's keep this up, I guess. Yeah. Is there
if that's,
a slide in the
all right.
background?
I'll turn off.
Cool.
I'll turn off the
Should I
video that never
move
worked.
somewhere?
I think you're okay.
Okay, great.
Come on. Get on the stage.
Hi, I am here. How are you?
Are
Hello.
you asking us?
No, I'm asking the stream that doesn't exist because it's all being recorded. Anyway, what should our phrase be this week? As I said.
Okay.
Save the planet.
Yeah, save the planet.
All right. Taking pictures.
Give me a second, my hips record and stuff.
3, 2, 1. Save the planet.
Let's go to the ball.
Save the planet.
Yay!
Captain Planet is zero.
Everybody just needs to watch the day the Earth stopped spinning.
Yay,
No, everybody
Dave
stood
Stroll,
still.
we're coming
Yeah,
on.
stood still.
Yeah, thanks so much for having me.
Good.
Really appreciate it. Hi, Blair. Good to see you.
Thank you very much for your time, sir.
Yes, thank you. It was great to be here.
Handshake.
That's right.
So I'm just gonna let that play.
Yay!
Well, thank
Yeah,
you,
that was really
everybody.
cool.
Hope it was useful. It was great to be
Yeah.
on.
It's really cool to have an expert.
Blair said they wanted to ask you some questions. Are you sticking around, or are you got to take off?
I'm happy to, if people have questions.
Sure,
Oh.
sure. Okay.
I do have something to tell you about, which relates to the topic we were talking about.
Stream
So we're talking about the banning of CFCs.
2, 1.